Welcome to The Explainer. So let's talk about something that underpins our entire digital world, trust. How do you build it between complete strangers online, without a massive bank or government playing referee? Well, the answer might just be blockchain, a technology it's shaking things up in a big way.
All right, so let's just start with this. It's a really simple question on the surface, but it's actually huge. Think about your life online. You're sending money to someone, maybe signing a digital contract. How do you actually know you can trust the person on the other end? Really think about it.
Well, for the most part, we've kind of outsourced that problem, right? We put our trust in these big middlemen. A bank steps in to verify a payment. The government issues your ID. A tech company gives you that little blue check mark. They are the trusted third parties for basically everything we do online.
But, and this is a big but, that whole model has a huge, glaring vulnerability. When you put all your eggs in one basket, when all the control and all the data is in one single place, you've created a single point of failure. What if that central server gets hacked, or just goes down? Or what if they just decide to change the rules on you? The whole system is at risk. Which leads to a really scary question. What happens when the middleman we're all forced to trust isn't trustworthy anymore?
Okay, so this is where blockchain just flips the script completely. It offers a totally different way of thinking. Instead of one central point of control, imagine spreading that control out among everyone involved. That's the whole idea of decentralization. You're not asked to trust one single company or government anymore. Instead, the trust is literally baked right into the system itself. It's a game changer.
And the engine that powers this whole thing is something called a distributed ledger. Now, the best way to think about this is like a magic notebook. Seriously, every time something happens, a transaction, a record, anything, it gets written down. But here's the magic part. Instead of just one person holding that notebook, an identical, magically updating copy appears in front of every single person in the network. Everyone has the same book, everyone sees the same history, all at the same time.
Okay, so right about now, you're probably thinking, wait a minute. If everyone has their own copy of the book and there's no boss in charge, how on earth do they all stay in sync, right? What stops someone from writing something fake in their own book? How does the entire network agree on what's true? This, my friends, is the absolute core challenge, the problem of consensus.
And to really wrap your head around just how mind-bendingly difficult this problem is, we have to talk about a classic thought experiment from computer science. It's called the Byzantine generals problem, and it perfectly illustrates the challenge of trying to get a group to agree when you can't be sure who's on your side.
So picture this. You've got several divisions of an army surrounding a city. They're all led by different generals. Now, they have to make a single coordinated decision. Either they all attack at once or they all retreat. It has to be unanimous, because if even one division attacks while the others retreat, it's a total disaster, complete defeat, and the only way they can talk to each other is by sending messengers across enemy territory.
But here's the real problem. What if some of those generals are traitors? A traitor could deliberately try to sabotage the plan. Imagine they send a messenger to one general saying attack and another messenger to a different general saying retreat. They're actively trying to create confusion and chaos. So if you're a loyal general, how do you possibly coordinate when you know some of the information you're getting might be a flat-out lie?
And get this, it has been mathematically proven that if just 1/3 or more of the generals are traitors, it is impossible for the loyal generals to reach a guaranteed agreement. Impossible. The system completely breaks down. They are paralyzed. And in our digital world, that's the equivalent of total chaos. No one would ever be able to agree on which transactions were real and which were fake.
So, if it's literally been proven to be impossible, how in the world does blockchain pull it off? Well, the secret is that blockchain isn't just one single technology. It's more like a cookbook with different recipes for building trust. And each recipe is designed for a very different kind of meal. So let's look at two of the most important blueprints.
All right, first up, the one everyone's heard of, Bitcoin. This is our case study for a public, or what's called a permissionless blockchain. Think of it as a global, wide-open network for digital money that anyone can join.
And to give you a sense of scale here, we're talking about a market capitalization that's well over $1 trillion. I mean, that's just a staggering number. And what it proves is that this wild idea of decentralized trust can actually work for millions and millions of people all over the globe, with absolutely no central bank or government pulling the strings.
So what does that word public really mean in this context? It means what it sounds like. It's completely open.
Anyone can connect to the network, you can see the entire history of transactions, you can send your own, you can even participate in validating new ones. There are zero gatekeepers. It's a come one, come all kind of system. So how does Bitcoin solve that impossible generals problem? It uses this incredibly clever system called proof of work. And here's the brilliant part. It doesn't try to identify the traders. Instead, it just makes it ridiculously expensive to be a trader. See, to add a new block of transactions, participants, we call them miners, have to solve an insanely difficult math puzzle. And solving that puzzle requires a ton of electricity and computing power. It's so costly that it's just not worth it for a trader to even try and cheat. So here's how that whole process plays out to keep things secure. Let's say Alice wants to send some Bitcoin to Bob. Her transaction gets broadcast out to the whole network. The miners all see it, they grab it, bundle it up with a bunch of other transactions, and then the race is on. They all compete to be the first to solve that puzzle. Whoever wins gets to add their block to the chain, and then everyone else in the network quickly checks their work and confirms it. And that's it. That's how the network reaches consensus, one secure block at a time.
Okay, but what if you don't want or need a totally open, anonymous global system? What if you're a business? Well, that's where a totally different blueprint comes into play, the private or permissioned blockchain. And a great example of this is Hyperledger Fabric, which is built specifically for the enterprise world.
So, if Bitcoin is like a public park that anyone can enter, a private blockchain is like an exclusive invitation-only club. You can't just show up, you have to be on the list. You need permission to join. And because of that, the identities of everyone inside the network are known. This completely changes the trust game. You're no longer dealing with anonymous generals, you know exactly who you're working with.
And this model is custom-built for business needs. I mean, think about something like a supply chain. You've got the manufacturer, the shipping company, the retailer. They all need to share data and trust each other. But there is no way they want their confidential business details broadcast on a public network for the whole world to see. For them, privacy and control are everything.
Now, since everyone in this club is a known and trusted entity, you don't need that super expensive proof-of-work system. Instead, Hyperledger Fabric can use a way more efficient process to reach consensus. It's a bit different. A transaction gets proposed, then specific members have to endorse it, give it the thumbs up. Then a special service lines up all the approved transactions in the right order, and finally, that new block is sent out to everyone to add to their ledger. It's a multi-step dance, but it's way faster and keeps things confidential.
So this really boils it all down. You've got public blockchains like Bitcoin on one side, totally open, anonymous, but because of proof of work, they're a bit slower. On the other side, you've got private ones like Fabric. They're fast, they're confidential, but they're restricted. They are two completely different tools for two completely different jobs. One is for building trust with strangers across the globe. The other is for streamlining work within a known private group.
So there's one thing you take away from all this. Let it be this. Blockchain is not one single thing. It's not just Bitcoin. It's really more like a whole new toolkit. It's a set of powerful ideas that lets us build systems where trust is a feature, not a bug, and to do it without relying on those traditional middlemen we've always needed.
And that really leaves us with a huge, exciting question, doesn't it? For pretty much all of human history, we've had to build our entire society around these central gatekeepers just to create trust. But now we have a completely new recipe, a new toolkit. So what old, seemingly unsolvable problems can we finally tackle now that we can build trust directly into our digital world? What comes next in this trust revolution?